At a dual console, the procedures officer coordinates activities and data requirements for the flight controllers in MOCR, while the instrumentation and communications engineer, INCO, assures correct operation of the command and lunar module's communications systems. The Flight Activities and Experiments Officer, FAO, keeps the flight plan updated and coordinates inputs to the crew during the mission. He also monitors the progress of experiments and crew activities. The network controller manages all systems around the world not on board the spacecraft. The assistant network controller is in charge of all systems in the Mission Control Center. And this all funnels to one position, the flight director, call sign flight. Working in shifts as the head of several teams of flight controllers, each flight director is responsible for key sections of the mission. Of the 3 or 4 flight directors assigned to a mission, one is designated prime, overseer of the entire flight. The assistant flight director is the flight director's leg man, analyzing trends and being a technical assistant. The 4th row of consoles is not involved in active control of the mission, but serves in several ancillary capacities. The public affairs officer observes the mission, keeps the press and news media informed, and selects television and audio lines to feed the media. The Director of Flight Operations has overall responsibility for all mission planning, flight control, and recovery operations conducted by the Manned Spacecraft Center. He provides policy guidance to the flight director during a mission. The Mission Director has overall mission responsibility and control of flight test operations. The Department of Defense representative controls all Department of Defense forces connected with the mission, including recovery forces, plus certain communications, and is responsible for search, location, and retrieval of crew and spacecraft. But here is the ultimate responsibility for all decisions made during a flight. Next to MOCR is the recovery room. A miniature version of MOCR, its personnel continually check ahead for contingency planning and to determine the status of the recovery forces. It is responsible for deployment of recovery forces and the return of spacecraft and crew. It takes over the mission once the spacecraft is descending on parachutes. The weather room keeps track of weather trends which could affect launch or recovery. During Earth orbital missions, its functions are particularly important to experiments calling for Earth photography or observation. The Mission Control Center, through the Apollo Simulation Checkout and Training System called ASCATS, can be hooked up to mission simulators at Cape Kennedy and at the Manned Spacecraft Center. This is to aid in training flight crews, flight controllers, and personnel of the tracking stations. Should electrical power fail, a generator plant on-site at the Manned Spacecraft Center can be used to keep mission control operating. But it is in support of a manned mission that mission control comes fully to life.
Yes, it's all right now. Okay.
Day 21, hour 15, minutes 4, 6 seconds, 5,
Voice communications. Communications, command and telemetry, CCATS. RTCC, the real-time computer complex. Display control system. Staff support rooms. Instrumentation support team. Recovery. Weather. MOCR, the Mission Operations Control Room.
We've passed T-minus 30, T-minus 25 seconds and counting, and Apollo 13 is go. T-minus 20 seconds, T-minus 20 seconds and counting. 17, guidance release, 15, 14, 13, 12, 11, 10, 9, 8. Ignition sequence has started. 6, 5, 4, 3, 2, 1, 0. We have commit and we have liftoff at 2:13.
The flight of Apollo 13 provided the ultimate test of mission control.
And it has cleared the tower.
Okay, Fido, how's it look?
Looks good here, flight. Good agreement.
Okay, Boost, how do you look?
S1C looks good, flight.
Okay, Capcom, we go you on the ground.
Cavalry leader flight.
Roger. Guidance, Roger.
Good flight.
Okay, Econ, GNC.
Looks good flight. Looks good flight.
Okay, Sergeant.
It looks fine. Through max fuel, we go flight.
Roger. This.
Apollo 13 was routine until 55 hours, 55 minutes into the flight.
Okay, Houston, we've had a problem here.
Flight guidance. Go guidance. We've had a hardware restart. I don't know what it was.
Okay. Houston, we've had a problem. We've had a main B bus undervolt.
You see an AC bus undervolt there, guidance? Or ECOM?
The first thing to do was to make sure that the problem was not an instrumentation failure.
We may have had an instrumentation
Next,
problem.
determine the severity of the problem.
Hallucinating, looking out the hatch, that we are venting something. We are venting something out into space.
Okay, let's everybody think of the kind of things we'd be venting. GNC, you got anything that looks abnormal in your system? Negative, flight. How about you, ECOM? That's a firm flight. Flight, I've got a feeling we've lost 2 fuel cells. I hate to put it that way, but I don't know why we've lost them. It doesn't all tag up. Network from flight.
Flight network.
Bring me up another computer in the RTCC, will you? GNC, can you get somebody in the back room to try to figure out what the equivalent delta V is we're getting so that we can see if we can backtrack to see if we can figure out what's venting.
It would later be found that an oxygen bottle in the service module had exploded. The decision: power down the command and service modules and use the lunar module as a lifeboat.
Tell me you from flight. Go ahead, flight. I want you to get some guys figuring out minimum power in the LEM to sustain life.
It was now up to mission control to get the astronauts back. Because of their position between the Earth and Moon and the condition of their systems, the crew would have to loop around the Moon, then head home. They were living in the lunar module, dependent on systems not originally designed for long-duration spaceflight. The object: survival. Booster, his job was over now. Retro, get them back to the recovery area in the best way. Fido, figure the best trajectory and the maneuvers necessary to do it. Guidance, keep that lunar module onboard computer honest. Surgeon, make sure the crew stays okay. Capcom, keep the information coming to the crew. Update those checklists. ECOM, monitor the systems and make sure we have enough left in the command module for re-entry. GNC, make sure we have attitude and guidance for the mid-course burns and re-entry. Telmu, watch the lunar module consumables. Keep the crew alive. LEM control, make sure the lunar module has attitude control, guidance, and propulsion to make the burns to get home. Procedures, keep the MOCR functioning smoothly in this crisis. INCO, maintain communications with the spacecraft. FAO, update the flight plan. Make sure the crew has time to get things done. And give them some time to eat and sleep. Network, keep the Earth-based systems functioning. In mission control alone, 10,000 miles of interconnecting wire and 2 million connections. Flight directors, it's on your back now. If you're not on duty, you're sleeping. You're in meetings to make survival decisions, or you're running simulations to develop spacecraft procedures and techniques. Staff support rooms, get cracking on the innumerable details involved. Recovery, weather, make sure they'll land in a safe area where you can get to them. Display, keep the information in front of the men who need it when they need it. RTCC, calculate, recalculate, and calculate again. Where are we? Where should we be? How do we get there? Instrumentation support team, keep the telemetry coming in and the commands going up to the spacecraft. ASCATs, get the simulators cranked up. There's hundreds of new emergency procedures now. They must be tried on Earth before the crew uses them on their crippled spacecraft. Voice communications, patch in everyone around the world who needs in. Keep them in touch. Then, 4 days after the accident, the crew jettisoned the service module to prepare for re-entry.
And there's one whole side of that station business.
Is that right?
The whole panel is blown out, almost from the base to the engine.
Really a mess. Man, that's unbelievable.
Then they jettisoned the lunar module that had been their home since the accident and made their re-entry.
Odyssey Houston, we show you on the mains. It really looks great.
They got back. Mission Control had done its job. Not just a collection of sophisticated electronics. For these devices are there to serve one purpose: to get the information to the man who needs it, when he needs it. For men must make the ultimate decisions. And they are Mission Control.